Hello everyone, in this video we will study 3-point estimating. This estimation method is essential to calculate activity duration or cost estimates. We can use two techniques here. The first one is PERT, program evaluation and review technique, and the second one is triangular distribution. So here's the breakdown of this video. First of all, we'll study PERT, beta distribution. We'll see how the formula calculates estimates based on weighted average. We will also calculate its standard deviation, and then we will calculate the estimates in terms of a range instead of a single date or time. And then we will study triangular distribution and also see where this method is most suitable. In the end, we will compare triangular distribution and PERT and see where these both methods are most commonly used. So let's start with PERT. PERT stands for Program Evaluation and Review Technique. This technique is used to estimate cost or activity durations. It can also be used to calculate overall estimation of the project instead of just a single activity. And it uses beta distribution and calculate estimates based on weighted average. So let's have a review of the formula. In PERT, you have three key time estimates. The first one is optimistic. Optimistic is the best case scenario. This estimate can be achieved if everything in the project goes perfectly. The second term is most likely. This most likely term is the most realistic one, which is most likely to happen in the project. And the third one is pessimistic term. This pessimistic term is the worst case scenario where we consider that everything in the project goes wrong. Now, to calculate the expected time to complete a task using PERT, the formula is this. You can see that the 4m term, this term is basically the most likely term, which is multiplied by a factor 4. This multiplication shows that the PERT formula is focused on the most likely term. So this formula gives you a weighted average, putting more emphasis on the most likely term. But an important question here is that why we have multiplied 4 with the most likely term and not with optimistic or pessimistic. It is because in real life, things usually don't go perfectly, nor do they completely fall apart. So the PERT formula helps you find a realistic middle ground. Now let's take a real life example. Imagine you are managing a construction project. You estimate that laying the foundation could take as little as 5 days if everything goes smoothly, but based on experience, it will most likely take 8 days. However, if bad weather hits, it could drag out to 15 days. Here you can see that the optimistic, most likely and pessimistic terms are explicitly mentioned, but in exam the questions would be tricky and you will have to analyze which formula should be used in the exam. It can be either PERT or triangular distribution. Here, to calculate expected activity duration, we have a PERT formula. We will simply put the values in the formula, so the answer would become 8.67 days. Here you could see that the question mentioned that it is based on the experience that the most likely term would take 8 days. This shows that the project needs historical data to calculate accurate results and make our planning better. Now, as we mentioned in the PERT example, that PERT basically deals with the uncertainty in the project. So how do we measure the risk of things taking longer than expected? That's where we use standard deviation. The probability of completing a project on exactly one date is very low. So it is better to develop our estimates in terms of range. So for PERT, our standard deviation is pessimistic minus optimistic divided by 6. One thing to note here, that if we have greater standard deviation in the project, the risk in the project would be greater. Now using the same example, we will calculate standard deviation of the activity duration we just calculated. So putting in the values, the answer is 1.67 days. This 1.67 days of standard deviation shows that the calculated activity duration could be completed 1.67 days before the calculated value or 1.67 days after the activity duration. So our range of estimate could be like this. It could take minimum 7 days or maximum 10.34 days to complete the foundation work. Now using the same formula, we will do cost estimation. Imagine you are budgeting for a software development project. You estimate the cost could be as low as 10,000, but historical data of similar projects indicate that it will be around 15,000. However, the maximum it can go as high as 25,000. It's the same easy question like we did before. Our optimistic cost is 10,000, realistic one or most likely one is $15,000, and the pessimistic cost is 25,000. After putting the value, the answer would be $15,833. So we should have a budget of around $15,833. This method helps us to ensure that we have enough funds set aside for the project even if things don't go exactly as planned. Now let's talk about triangular distribution. Like PERT, it is another way to estimate time or cost. Triangular distribution is simpler than PERT because it gives equal weight to each of the 3-point estimates. Here is the formula of triangular distribution. Again, you can see that triangular distribution also uses the same three factors: optimistic, most likely, and pessimistic. But instead of calculating it in a weighted average, here we take a simple average of the term. The downside of this formula is that it does not take into account the historical data to make more accurate predictions. So for triangular distribution, we don't need historical data. It can be used for rough estimates, which is useful in certain situations. Now we'll use the same construction project example like we did in the PERT formula and calculate the value. Here you see that the activity duration is 9.33 days. It is more than the one we calculated in PERT formula, which was 8.67 days. One more important thing to mention here is that the standard deviation of triangular distribution gives a larger value compared to PERT. So for our foundation example, our standard deviation would be greater than the one we calculated in PERT. However, in this video, we have not covered standard deviation of triangular distribution. Now let's compare triangular distribution and PERT. The first one is estimation method. PERT formula uses weighted average while triangular distribution uses simple average. The second thing is the focus. PERT is focused around the most likely term. It gives a more balanced and realistic outcome. But triangular distribution treats all the estimates equally. So it is less realistic, but it is more easier. The third point is accuracy. The PERT formula, since it uses historical data, the outcome of this formula is generally more accurate than the triangular distribution. The fourth point is data requirements. Obviously, the data requirement is more detailed in PERT because it uses historical data, and triangular distribution has a minimal requirement because it treats all the estimates as equal. The last point is use case. PERT formula is ideal for projects with significant uncertainty and when more accurate time estimates are needed, while triangular distribution are useful for quick and rough estimates when precise data is unavailable. So we can say that PERT has the ability to incorporate uncertainty and provide a weighted average, which makes it a go-to method for project managers dealing with complex and uncertain projects. So that's it from this video. In this video, we studied PERT, triangular distribution, and also discussed standard deviation, how it helps you to manage uncertainty. So if you found this video helpful, please make sure to subscribe the channel. Thank you.